One, we're going to talk about oblique triangles. So our oblique triangles are triangles that have no right angles. So before we were dealing with right triangles, we used SOHCAHTOA to solve right triangles or Pythagorean theorem. You can't do that when it's not a right triangle. So we're going to talk about different strategies on how to solve oblique triangles, so non-right triangles. Now, it's important to understand the labels of our triangles. So when we have capital letters, that's going to denote the angles. When we have lowercase letters, that's going to denote the sides. And then the corresponding letters are opposite of each other. So angle A is going to be opposite of side A. Angle B is going to be opposite of side B. And angle C is going to be opposite of side C. So it'll give you 3 pieces of information for your triangle. It might give you 2 sides and an angle, or 2 angles and a side, or all 3 sides. And you're going to have to come up with the other 3 pieces of information. So in every triangle, you have 3 sides and 3 angles. So you'll have 6 pieces of information. 3 will be given. The other 3 are going to be ones that you have to find. Now, we are going to talk about an ambiguous case. So when we have side, side, angle, it is possible that we could have 2 triangles. So we have to check for 2 triangles, which we'll do examples of that. But when you have side, side, angle, so 2 sides are given and not the included angles given, then you have to check for 2 triangles. So we are going to use the law of sines to solve our triangles. So our law of sines is a proportion that's set up between the pairs of angle and sides. So we have side A, so lowercase a is side A, over sine of angle A, which is going to be equal to lowercase b, so side B over sine of angle B, which is equal to side C over sine of angle C. So the lowercase letters up top, remember, are the sides. Capital letters are the angles. You can only take a trig function of an angle, so make sure you're careful with that. Now this is all 3 proportions equal to each other, but you're just going to set one fraction equal to another fraction to help you solve. You're not going to have an equation with 3 of them, but you can say A over sine of A is equal to C over sine of C. You can set it up however you want, but make sure you're consistent with that. And by consistent, let's look at the next page. You can also flip it and say sine of A over A is equal to sine of B over B, which is equal to sine of C over C. So if you want to do the angles on top, you can, but just make sure you have an angle on top is equal to an angle on top over the sides on the bottom. So be consistent with it. It doesn't matter which order you have. You can have sides on top or sides on the bottom. Just be consistent with it. So let's look at example 1. Here it gives us the picture. It's not always going to draw the triangle for you. You don't need the triangle when you're solving these. You always want to start with the pair that you're given. So I have side B is the lowercase one, and angle B. So I'm going to start my proportion with the B's. So always with the pair that you're given. So we have 27.4 over sine of the angle, so 28.7. Then that's going to be equal to, the next piece of information we have is angle C. So I'm going to use angle C to help me find side C. So I want to find its pair. So I'm going to say C over sine of the angle, 102.3. Now to solve here, we're going to cross multiply. And then we want to get C all by itself. So we have 27.4 times sine of 102.3 is equal to C times sine of 28.7. Again, we got to get C all by itself, so I'm going to divide both sides by sine of 28.7. Then we're going to put this into the calculator. Be careful when you put it into the calculator. If you do it all together, I would recommend putting the top in parentheses. Or you could do the numerator, put equals, so it gives you a number, and then just divide it by the denominator. Just make sure you know how to use your own calculator. Every calculator is different. Make sure you know how to use yours. So we have 27.4 times sine of 102.3. I'm going to put equals to give me a number, and then just divide that by sine of 28.7. So you should get C equals 55.74, so I'll just call it 55.7. 55.7 what? What unit are we talking about here? Feet, awesome. It gives us feet, so this will be feet. So side C is 55.7 feet. So this is our first answer. Again, it gave us 3 pieces of information. We're going to need to come up with the other 3, so we have 3 answers that we need to find total. So we found 1. Next, we're missing angle A and side A. So let's find angle A first. So if it gives us 2 angles of the triangle, what do we know that all 3 angles are going to add up to? 180. So I can add the 2 angles that are given and subtract from 180, or just do 180 minus the 2 angles, minus 102.3 minus 28.7. Same thing. You could either add them together, subtract from 180, or just subtract them separately. Just put it into your calculator. We have 180 minus 102.3 minus 28.7. So you should get 49 degrees. So angle A is 49 degrees. So now we're just missing side A. So I'm going to do the same thing I did before, where I need to set up a proportion. I always want to start with the given information. So since B's were given, I'm going to use that same proportion that I did to find C to find A. So I'm going to start with the givens. So we have 27.4 over sine of 28.7 is equal to, I'm going to set up a proportion with my A's. So since I did the side on top, I'll put the side on top here. So A over sine of 49. So you always want to start with the given one, just in case something went wrong in the math where I found side C. You don't want to do the math with the wrong answer for the rest of the question. So start with the given one, just use what was given to find the rest of it. So same thing that we did to find C, we're going to do to find A. We're going to cross multiply. So 27.4 times sine of 49 is equal to A times sine of 28.7. Divide both sides by sine of 28.7. And then we put this into the calculator. Just be careful when you're putting it into the calculator. 27.4 times sine of 49 divided by sine of 28.7. So you should get A is equal to 43.06. I'll call it 43.1. 43.1 what? Feet, perfect. Now be careful with your calculator. We're talking about degrees here. All of our angles are going to be in degrees, so your calculator needs to be in degrees. Just make sure your calculator's in degrees. If you're not getting the right number, but you're setting it up right, just make sure that your calculator's in degrees. One other thing that you can do to check your work is that the largest angle is always going to be opposite of the longest side. So you can just check your work that way. Our largest angle was 102.3, so side or angle C. So it's opposite of our biggest side, so 55.7. So that's true. You can check it with the smallest one. Your smallest angle is always going to be opposite of the smallest side. 28.7 is opposite of our smallest side, 27.4. So that's true too. So that's one way to check your work. It doesn't really tell you if you did the math right or not, because your answer still could be a little bit off. But if you have an angle that's the largest angle and it's not opposite of the longest side, you did something wrong. So it'll tell you if you did something wrong that way. So always just check. Just once you find all your answers, just quickly check at the end. Is my biggest angle opposite of the largest side? So here we're given two angles and the side in between. So we don't have to worry about our ambiguous case yet. It says the pole tilts towards the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So it gives us the picture here. This angle is our angle that's given. What would the measure of this angle be? Angle B. 98. Awesome. It's 90 degrees plus the 8-degree tilt that we have. So this would be 98 degrees. So I have two angles. How would I find the third angle? How do I find angle C? Awesome. Add them together and subtract from 180. So we have 180 minus 98 minus 43. So this would be 39 degrees. All right, so now what proportion can we start with? Were we given a pair of side angles? Do we have a pair of side angles?
Yes.
Which one? C. We have angle C and side C, so that's what we're going to start with. So we have 22 over sine of the angle, sine of 39, is equal to, now it doesn't matter what we find next. You could find, we're still missing side A and side B, so just find either one next. I'll start with A. So this will be equal to A over sine of angle A, which is 43. Cross multiply. So 22 times sine of 43 is equal to A times sine of 39. Divide both sides by sine of 39. So A is equal to, we're going to put this into our calculator. So you should get A is equal to 23.8. 23.8 what? Feet. Perfect. Our unit here is feet. Last thing we need to find is B. So I'm going to do the same thing. I'm going to start with the proportion that I had from the beginning. So 22 over sine of 39 is equal to B over sine of 98. We're going to cross multiply. So 22 times sine of 98 is equal to B times sine of 39. Divide both sides by sine of 39. So B is equal to 22, we're going to put this in the calculator. 22 times sine of 98 divided by sine of 39. That should give you 34.6. So B is 34.6 what? Feet. Perfect. Now just to make sure, double check that your largest angle is opposite of the longest side. So 98 is our largest angle, 34.6 is the longest side. Our smallest angle is 39, which is opposite of the smallest side, 22. So you just double check your work that way. So our ambiguous case is when we have side-side angle. So when you're given two sides and not the angle in between them. It is possible that we could have no triangle We could have one triangle, or we could have two triangles. But you always, always need to check for two triangles. Except when you have no triangles. When you have no triangles, you'll see in the example that your answer is no triangle. But if you have one, it is possible that you could have two, so you got to check. So any time that you have side-side angle, you got to check for two triangles. Here's a picture of like what the ambiguous case could look like when we have a possibility of one triangle, two triangles, or no triangles. Don't worry about this slide. Let's go to the next one. So let's look at example 3. So here we're given two sides and an angle. It's not the included angle. So two sides and an angle. We have to check for two triangles. When you know that it's side-side angle, I would always start by just drawing a little chart over here. Each triangle has 6 pieces of information, so it's super important that you're organized with your work. So I'm going to draw a little chart for our triangle 1 and triangle 2, possible triangle 2. I'm going to start with my given information. So angle A is given, which is 42 degrees. Whatever's given is going to be the same in triangle 2. So angle A is going to be 42 in triangle 2 as well. And then we also have side A and side B that are given. So side A is 22 and side B is 12. So these are going to be the same in triangle 2. Now, do we have a pair that we can start with? A, we have angle A and side A. So that's what we're going to start our proportion with. What do we have to find next? B, because we were given side B, so we have to find angle B next when we set up our proportion. So 22 over sine of 42 is equal to B, which is 12, over sine of B. So we're going to cross multiply just like we did before. So 22 times sine of B is equal to 12 times sine of 42. Divide both sides by 22. So sine of B equals, we're going to put this into our calculator. So 12 times sine of 42 divided by 22. So we get 0.3649. It keeps going, but I'm going to leave it in the calculator. This isn't our final answer because we still have that sine. Sine of B equals this. How do I find what angle B equals? What do we have to do? Not really divide by sine. We take the inverse sine. So that's sine -1 button in our calculator. So sine to the power of -1 is the inverse sine. It'll cancel out with our sine there. We're left with B is equal to, we're going to do the inverse sine. So in my calculator, I click second sine to do the inverse, and then second answer to just copy and paste the answer. So you get 21.4. What are we talking about here? If it's angle B, degrees, perfect. 21.4 degrees. Any questions on how we found that? Let's find angle C next. If we have two angles, how do we find the third? Add them up and subtract from 180. So 180 minus 42 minus 21.4. So we get 116.6. 116.6 degrees. And then the last thing we have to find for triangle 1 is side C. So we're going to set up our proportion. I'm going to start with the same proportion that we started with here. So 22 over sine of 42 is equal to side C over sine of 116.6. Same thing we do to start, cross multiply. 22 times sine of 116.6 is equal to C times sine of 42. Divide by sine of 42. Then put it in the calculator. 22 times sine of 116.6 equals, and then divide that by sine of 42. So C is equal to 29.39. I'll call it 29.4. 29.4 what? Inches. Awesome. We're talking about inches here. 29.4 inches. All right, so we did the same thing we were doing in the first couple examples. We found all of our important information for triangle 1. We solved triangle 1. Now we want to see if we have two triangles. Now to do that, we always want to take the first angle that we found. So after the given, what was the first angle we found? B. I wrote it here first so we can be organized and we know what we're doing. So B was the first angle we found. I'm going to do 180 minus angle B. So our new angle B, or triangle 2 angle B, is going to be 180 minus 21.4, which would be 158.6 degrees. So to find your new triangle angle B, you do 180 minus angle B. So always the first one that you find. Now from here, how do we find angle C, our new angle C? We add them up and subtract from 180. So I'm going to add these two up. We have 158.6 plus 42. We get 200.6. What do we get when we subtract this from 180? When we do 180 minus 200, what do we get? A negative 20. Is it possible to have a negative angle? Is it possible for two of our angles to add up to more than 180? No, because we can't have a negative one. So here we have no second triangle. We only have one triangle. So this is what it looks like when you have a side-side angle with only one triangle. You have to check for two because it is possible that you could have two. But if your two angles add up to more than 180, then you can't have a second triangle. Because you can't have two angles in a triangle that add up to more than 180. Not possible. So you can just stop here. This would be our answer. All of this that we found. So you still have to find all your important information for triangle 1. We just don't have a second triangle. So sine 25 times sine of 85 divided by 15, that gives us 1.6603. It keeps going, but I'm going to leave it in the calculator because we're not done yet. We have sine of B equals this. How do I get B all by itself? Inverse sine. So I'm going to do the sine, it's the power of -1 button in our calculator, the inverse sine. So that gives us angle B. When we take the inverse sine of 1.6603, do second sine, second answer, what do we get in our calculator? What does it say, Mia? What did it say?
It's not working.
Why not? What did it tell you?
Sine x, it's no main error. Keep saying
Error.
Oh.
You're doing it right.
Oh.
It gives us an error. Error is not our final answer. What do you think it means when we have error? Do we have a triangle? No, we would have no triangle. So if it tells you error, you have no triangle. So it is possible in your ambiguous case when you have side-side angle that you could have no triangle. You'll get an error when you do the work. A side-side angle, we're given two sides and a non-included angle, so not the angle in between them. So we have to check for two triangles. So since we have to check, I'm going to start with my little table here just to be organized with our work. We have triangle 1 and triangle 2. The angle that's given is going to be my first thing, so angle A is 20.5 degrees. It's going to be the same in both triangles, 20.5. And then side A and side B are also given. So A and B, A is 12 and B is 31. So this is going to be the same in both triangles. We just start with our given. What do we have to find next? Angle B, perfect. I have my pair here, so side A and angle A. And then we have side B, so we have to find angle B. So 12 over sine of 20.5 is equal to 31 over sine of B. So we want to cross multiply first. We get 12 times sine of B is equal to 31 times sine of 20.5. Divide both sides by 12. Bless you. So sine of B is equal to, let's put this into our calculator, 31 times sine of 20.5. I'm going to put equals and then divide by 12. Did you get 0.904? Does that sound right? Okay. We're going to leave it in our calculator. What do we have to do next? The inverse sign, so sine -1 button. So second sign, second answer. We get B, angle B equals 64.78, which I'll just round to 64.8. So angle B is 64.8 degrees. All right. How do we find angle C? Add them and subtract from 180. So I'm going to do 180 minus 20.5 minus 64.8. So 180 minus 20.5 minus 64.8. Get 94.7. It's 94.7 degrees. Missing one more thing for triangle 1. What are we missing? Side C. So let's set up our proportion to find side C. I'm going to start with the same proportion that we were given. So 12 over sine of 20.5 is equal to side C over angle C, sine of 94.7. Cross multiply to solve, we get 12 times sine of 94.7 equals C times sine of 20.5 divide by sine of 20.5. So we get C equals, let's put this into our calculator, 12 times sine of 94.7 divided by sine of 20.5. Should get 34.15. I'll call it 34.2. 34.2 what? Meters is our unit here. Perfect. Now let's check and see if we have two triangles. So what do we need to do to check to see if we have two triangles? Awesome. 180 minus angle B. It has to be 180 minus the first angle you found. So our new angle B is going to be 180 minus 64.8, which would be 115.2. So 115.2 degrees. How do we find our new angle C? Add angle A and angle B and subtract from 180. So when we add these two, we get 135.7. So it's less than 180, so we're good there. We're going to do 180 minus 135.7. So we get 44.3 degrees, bless you, is our angle C.
Wait, which two did you add? One did you add?
The first two angles here. So A was given, B was the next one that we found. So once we have two angles, just add them and subtract from 180 to find your third. Last thing we're missing is side C. So we have a new side C for triangle 2. We're going to set up our proportion just like we did before. So I'm going to start with the one that was given. So it's the same, your given information is the same in triangle 2. So we have 12 over sine of 20.5 is equal to our new, well, side C over our new angle C. So sine of 44.3. We are going to cross multiply. So 12 times sine of 44.3 equals C times sine of 20.5. Divide both sides by 20.5. Sine of 20.5. So we get C equals 23.9. 23.9 what? Meters. Perfect. So here we have two triangles. We've got 3 answers for each of our triangles, so just make sure you are organized with your work. The area of an oblique triangle. After we do 6.2, you'll have 3 area formulas that come up. So we'll give you the area formulas. You don't have to memorize them. You just have to know when to use which one. So for 6.1, our area formula is on the next page. When you have 2 sides and their included angle. So if I had a triangle here and I was given side, side, and the included angle, so the angle in between the 2 sides, we use one of these 3 formulas. So it just depends on which 2 sides, but these are all the same formula here. So it's 1/2 times side C times side B times sine of angle A. So sine of the included angle. Remember, you're always doing sine of an angle. You never do sine of a side. So all 3 of these are the same. Let's look at example 6. So our area formula is 1/2 times the side, so 52, times the other side, 90, times sine of the included angle, sine of 102. Just be careful when you put this into the calculator. If you do it all together and you leave it as 1/2, definitely put the 1/2 in parentheses. So we have 1/2 times 52 times 90 times sine of 102. That'll give you an area of 2,288 it's 86, so I'll just call it 9, so 0.9. What unit do we have here? Our area would be what? Meters squared, perfect. So that would be our answer.